The concept of managed and external tables in data lakes tends to cause a lot of confusion. In this video, I'm going to try to remedy that by showing you what happens when you create and drop both managed and external Hive, Delta Lake, and Iceberg tables using Starburst Galaxy. In my examples, I'll be using Amazon S3 for storage, but you can apply these concepts to other clouds as well. Let's begin with some definitions. A managed or internal table is one where both the data and metadata are managed by the metastore or catalog. An external or unmanaged table, on the other hand, is one where the data files are not managed by the metastore or catalog. With external tables, management of the metadata depends on the table type, as you'll see later in this video. The key difference between managed and external tables is what happens to the data files when a table is dropped. In the case of managed tables, when a table is dropped, all of the accompanying metadata and data files are deleted. For external tables, when a table is dropped, the metadata and data files remain, except in the case of Hive. When you drop an external Hive table, the metadata is deleted, as you'll see later. Okay, now that we have the definitions out of the way, I'm going to head over to Starburst Galaxy to show you what this looks like in practice. I'm going to begin with a managed Hive table, but first let's take a look at the catalog I'll be using for all of the examples in this video. As you can see, it's connected to S3. And here I have a default S3 bucket name and default directory within that bucket. I'll be specifying the location of all the schemas I create in this video, but if I didn't specify a location, this default location would be used for managed tables. Another thing to notice is that my default table type is Hive. When you set the default table type for a catalog, you're ensuring that if a user creates a table without specifying the table format, the default format will be used. A user can still choose to specify Iceberg or Delta Lake if they want. Again, this is just meant to be the default when the user doesn't specify. Now let's head over to the query editor to start working with a managed Hive table. The first SQL command I have here is going to create a schema for me. Notice that I've identified the location within my S3 bucket that I'd like to use. That means that I won't have to specify the location when I create the table. So let's go ahead and run this. And it came back successfully. And if I come over here and refresh my catalog in the Catalog Explorer, you can see the schema that was created. And of course, there's no table there yet because I haven't created it yet. But this next rather long SQL command is going to create my table for me. What I'd like to point out here is that I've identified the file format I would like to use, in this case Parquet. I also have the table format specified, even though I technically don't need it because my default table format is Hive. So let's run this. Okay, that came back successfully. And if I refresh my schema, now I can see the table there. Now at this point, if I go and look at my S3 bucket, I'll see that nothing has changed because I haven't added any data to the table yet. Once I do add data, the table files will be created in S3. So let's just go ahead and check that out. And I'm going to go under the Managed folder, and you can see that nothing is here yet. I do want to point out that this behavior is unique to Hive, and part of this is due to the fact that Hive metadata is stored in the database that backs the Hive metastore. As you'll see soon with Delta Lake and Iceberg, when I create the table, the directory structure for the table name and metadata will be created even before I've added data to the table. But let's go back over to add some data to my table. And you'll notice that this one will take a copy of all the data in the tpcds.tiny.callcenter table and insert it into the table that I just created. So I'll run that. And now I'm going to query my table to make sure that the data was added. Okay, looks good. Now let's head over to my S3 bucket to see what happened there. So if I refresh the page here, I can see that the Hive folder was created, and then Tiny, and then finally Call Center, which is the table name. And now if I go in there, I can see that there is a single file for the data, and that's of course Parquet because that's what I had specified in my SQL statement. I don't see a metadata folder here because again, the Hive metadata is managed by the metastore. Okay, now I'm going to go back to Galaxy, and I'm going to drop the managed Hive table with the drop table command. Because this is a managed Hive table, I expect both the data files and the metadata files to be deleted. So let's run this here. Now if I go back over to S3, I can see, I'm going to come back to the managed level, the entire directory structure was deleted. So everything was deleted when I dropped the table. Next up, I'm going to work with an external Hive table. Oftentimes, external tables are beneficial because if the table is accidentally dropped, the data remains. And with Hive in particular, if your data already exists in CSV or JSON format, you can create an external table over that data. I'm going to go through this one a bit faster because the steps are almost the same as the managed Hive example. So let's go back over here. And first I'm going to create another schema. And again, I'm specifying the location. So let's run that. Next, I'm going to be creating the same table as before, again specifying the table format and type. The key difference here is that I'm specifying the external location as well. And this is the part of the statement that tells Starburst that I want this to be an external table. So let's go ahead and run that. Now let's add some data to the table as I did before. And now I'm going to query the data to make sure that it was added. And you can see that it's the same as the table that I created before. So let's go over to AWS again. And this time I have to go back up one level because I need to go into my unmanaged folder. And you can see that, again, a Hive folder was created, and then Tiny, and then Call Center, again with a single file inside. Okay, let's go drop the table to make sure that afterwards the data file is still there in my S3 bucket. So here's the drop table command again. Okay, now back to S3. And if I go back up to the unmanaged level, I can see that the entire directory structure is still there, including the data file. Now that we've gotten Hive out of the way, I'm going to focus on Delta Lake. I'll be using the same S3 bucket and the same catalog as before, and again, I'll start with a managed table. I'll start again by creating the schema, and just like with Hive, I've identified the location. I'm creating a call center table again, but this time I've only identified the table type in the with clause. Let's go ahead and run that. Now let's head back over to AWS to check that the table directory structure was created even before I add data to my table. So I'm going to go back here, and I'll go back to the managed folder. And you can see here I have my Delta Lake folder, and then inside that the Tiny folder, and then I have a call center folder. Notice the string of random numbers and letters that was added to the name of the folder. This is something that happens with both Delta Lake and Iceberg, and it's another reason you might consider using an external table so that you can control the naming convention. Now inside this table folder, I have a Delta Log folder. The Delta Log stores the metadata for and keeps track of all the transactions on a Delta Lake table. So if I go in here, I can see I have one file that's keeping track of the fact that I just created the table. So let's go back and add data to the table. Now notice that there are a lot of casts that I have to include when I add the data. I won't get into that because it's not the topic of this video, but there are some data types that don't exist in Delta Lake that I have to convert. So let's go ahead and add that data. Now let's query the new table. And you can see that it's the same as when we created it with Hive. And now let's head over to S3 to see the results. So if I go back up one level, you can see that now I have a data file that wasn't there before. And if I go into my Delta Log again, you can see that a new log file was added. Okay, now I'm ready to drop the table. So let's go back to Galaxy to do that. So here's the drop table command. And now if I go back to S3 and go all the way back up to the managed level, you can see that the entire directory structure is gone once again. Okay, now it's time to look at an external Delta Lake table, which Delta Lake actually calls an unmanaged table. The terminology is a bit different, but it's the same idea. So once again, I'll begin by creating a schema with the location identified. Then I'll create the table itself and make sure that I've identified the table type and location. And again, identifying the location in the create table statement is what will make this an unmanaged table. Let's run that. And now I'll add my data to the table, again with a bunch of casts. Okay, now let's query it to make sure that everything looks okay. Okay, looks good. And now let's go over to S3 to check it out. So we'll go back to unmanaged. Okay, once again, a new directory structure was created. And again, we have the call center folder, and inside is the data file and the Delta Logs folder. Okay, let's go drop this table to make sure that the files don't disappear when we do so. Let's go back over here. And here's the drop table command. Okay, back over to S3. And I'll go back up. Okay, so everything is still there. And then if I go into the Delta Log, I can see that I have two Delta Log files in here. Unlike we saw with Hive, when we drop an unmanaged Delta Lake table, the metadata remains. So keep that in mind. And one thing that I do want to point out with Delta Lake, which is also true for Iceberg, if you want to create a table over existing data, you cannot use the create table command. Instead, you have to register the table. I'm going to use the data from the unmanaged table that I just dropped to illustrate this. So if I go back over here, and I'm going to refresh my catalog, and then I'm going to go to the Unmanaged Delta Lake schema right here, you can see that there's no content. Because I dropped the table, you can't see it here, even though the data files and the metadata files still remain in S3. So I'm going to now register the table so that the table comes back. And I'm going to put the command up on screen here for you so that you can take a closer look. It's very similar to the create table command in that I'm identifying the catalog and schema that I want to use, as well as the location of the data. So let's run this. Okay, and over here I can confirm that it was created by refreshing. Okay, so there's my table again. And then if I go back over to AWS just to check, you can see that there have been no changes here. Okay, so back to Galaxy. And now if I want to get rid of this table, what I have to do is unregister it. So here's the command right down here. And I'm going to run that. And if I check over here and refresh the schema again, you can see no content. But again, if I go back to AWS, I can see that my data still remains, as well as the metadata. All right, we've covered Hive and Delta Lake. Now, last but not least, we have Iceberg. One important thing to keep in mind about Iceberg is that with Iceberg, all tables are managed. This means that even when we specify an Iceberg table's location in a create table statement, the table is still managed. And if we run the drop table command on an Iceberg table, the data is always deleted. Let's take a look at this. I'm going to still be creating two tables like I did with Hive and Delta Lake, and I'll be calling them managed and unmanaged, even though they're all technically managed. This is just to illustrate the behavior of Iceberg tables when I create them in different ways. I'll once again create a schema to begin with and identify the location. Now I'm going to create the table itself, and you can see that I've included the format and table type in there. And then the SQL to add the data has a bunch of casts in it again, just like we had with Delta Lake. And again, this is to make sure that the data types are all converted to ones that are accepted by Iceberg. So let's run that. Okay. Now let's query the table. Okay, looks great. And now I'm going to head over to AWS to check out the results. So I'll go back here, go back to managed. Okay, here I see my Iceberg folder. And here's the tiny folder. And now I have the call center folder with the random string of letters and numbers after it. And if I click into that folder, I have two other folders, one for the data and one for the metadata. And I'm not going to get into what all the metadata files are for. I actually have a separate video that covers that in depth if you're interested. Okay, now let's drop the Iceberg table. Let's go back over here, and here's my drop table command. And let's go back to S3 just to check that everything's gone. And it is. Okay, next up I'm going to create an Iceberg table and specify the location. So let's go back over here. And I'll once again create the schema first and identify the location. And here we have the create table statement. And you can see the location identified there as well. So let's run that. Now let's add the data. And then after I'm going to go over to S3 to check it out. So here's the command to add the data. Okay, so back to S3. And let's go to unmanaged, Iceberg. Okay, so the folder structure is the same, but with one key difference. We now just have call center as the name of the table folder instead of that random long string of letters and numbers that we had before. And then inside there, you can see the data and the metadata folder as well. Okay, let's go drop the table to confirm that the data will be deleted. So back over and the drop table command. Okay, so let's go over here. Okay, everything's gone, and that should stress the importance of not using drop table on an Iceberg table. Let's look at the alternative, which is to unregister the table instead. So I'm going to go back over here, and I'm going to quickly recreate the schema and table and also populate the table so that I can illustrate the use of the unregister command. So let's create this schema and create the table. and we'll populate it. Before we use the unregister command on our Delta Lake table, and this one is pretty much the same thing, just using Iceberg. So I am going to run that command. And you can see it was successful. And if I go over here, I'm going to just refresh everything again so that I can take a look and make sure that I don't see the table anymore. So here's the unmanaged Iceberg schema. Okay, so no content, but if I go over to S3, I'm going to refresh this, and you can see that the Iceberg table structure is still there, which is great. The data and the metadata are still there. Okay, so the final thing I want to do is just re-register that Iceberg table to show you that it'll show up in our Catalog Explorer again. So here's the register table command, and I'm going to run that. Okay, and then if I refresh over here, the table's back. And that's all for this video. Thanks for watching.